So here I'm showing a solid square-based pyramid, which is the diagram below. And I'm told that the base of the pyramid is a square of side 6 centimetres. So I can see that here. This length is 6 centimetres, and then this length, and this length are also all 6 centimetres because the base is a square. I'm then told that the height of the pyramid is 4 centimetres. So I can see that this line here from the centre of the base to the top of the pyramid, point V, is going to be 4 centimetres, that distance there. And finally, I'm told that M is the midpoint of BC and VM, and it's equal to 5 centimetres. So this is BC, and then VM, the line, is going to be equal to 5 centimetres, and M is this midpoint on BC. So we're then asked to draw an accurate front elevation of the pyramid from the direction of the arrow. So this is the direction, we're looking at the pyramid in this direction, and we're asked to draw what it would look like. So we're basically going to be seeing one face of this shape. We're going to be seeing the front face. And I know that the length of the base here is going to be 6 centimetres, and I'm going to see this. This is going to be at the bottom of the front elevation. So I can draw a 6 centimetre line at the bottom, and if I take each small square to equal 1 centimetre, we have a 6 centimetre line here. I can label that one up. And then if I look at the diagram, looking from this direction, this face and the face obscured here, as well as the back face, are all going to be obscured by this front face that we're looking at. So in the front view, we're simply going to see this triangle here, AVB. That's all we're going to see looking at this square-based pyramid from the front. So we're basically going to be looking at a triangle. Now the height of the triangle isn't going to be this 5 centimetres, that's a diagonal height across this distance. It's going to be this 4 centimetres here, which is the distance V is from the line AB vertically. So V is 4 centimetres vertically above the line AB. And V is going to be halfway in between A and B horizontally, so 3 squares in between. So I can mark that point up. And then it's going to be 4 squares above. So 1, 2, 3, 4. This is the point where V is going to sit. And then I can just attach these points to this top of the triangle. And it's going to leave us with an isosceles triangle. So this length down the centre is going to be 4 centimetres. So it's an isosceles triangle that we will see with a base length of 6 centimetres and then a height of 4 centimetres. And that's going to gain us both of the marks here for understanding that it's going to be a triangle firstly, and then for getting the correct side lengths and orientation of the triangle. And now I'm asked to work out the total surface area of the pyramid. So I can see from the diagram, this pyramid is made up of its square base, so this face which is on the bottom, and then 4 identical triangular faces, which are all going to have the same area. So the surface area here is effectively one lot of the square base, and then we're going to be adding on 4 lots of these triangular faces because there are 4 triangular faces. And then I can start here by looking at the square base, as it's going to be easier to work with. It's AB is on length 6, BC is also 6 centimetres, they're all going to be 6 centimetres. So the area here is simply going to be 6 multiplied by 6, and that gives us an area of 36 for the base. And now we need to add on 4 lots of the area of one of the triangular faces. So if I redraw the diagram of one of these triangles, I can then take the base length, so 6 centimetres here, and then this length of the triangle. Now this isn't going to be the height of the pyramid. It's not going to be this 4 centimetres. It's going to be the distance between the top of the triangle and the midpoint on its base. So the distance VM, which we're told is 5 centimetres. So I now know that this one's 5 centimetres. Now the area of a triangle is going to be a half base times height. And in this case, it's going to be a half times the base, which is 6, times the height of the triangle, which we've calculated to be 5. And that gives me an answer of 15. So now I have the area of the square base and an area of one of the triangular faces. I can simply add them together. So I have the 36 for the square base, and I'm going to be adding on 4 lots of these triangular faces, the area of that, so 4 times 15, and that's going to give me 36 plus 60, which gives me a final answer of 96. Now this question is worth 4 marks here, so it's going to require quite a bit of working out, and as we can see in the question we are given the units for each of the lengths, and there's no units predetermined in this question. So in order to obtain the last mark, we're going to have to work out the units. And we're working with area, so surface area, and that's going to give us a unit of something squared. And here we're working with centimetres, so I've done 6 times 6 centimetres multiplied by centimetres, which is effectively what I've done. Is going to give me the unit of centimetres squared, which is the unit for area in this case. So to give my final answer and gain all 4 of the marks, I'm going to write 96 centimetres squared. So if I go back through and see exactly where I picked each of the marks up individually, the first mark would be for working out the area of one of the triangular faces, so getting that 15. Secondly, for then working out the total surface area, so by taking the 4 multiplied by 15 and adding on the 6 multiplied by 6 to get this surface area for attempting that. And the third mark's for obtaining the correct answer of 96, so this numerical answer here, that gets me the 3rd mark. And then the final mark is for the units. Putting the units on the end, the centimetres squared, gains the 4th mark in this question.